Hello. In the last videos, we discussed what are greedy algorithms and some questions. Let's come to the next one. So here is the question. Read it and give it a try. In a day, an account holder at hacker bank wants to make n transactions. In each transaction, money is either sent negative amount or received positive amount. Given n transactions 1 to n, transactions may be skipped. The balance starts as 0 and is the running sum of selected transactions. It can never go negative. Find out the maximum number of transactions possible. So the question simply asks that we have to select a subsequence such that every running sum is positive. Let's say the subsequence is x, y, z, and p, and so on. So the first one should be greater than equal to 0, and the sum till second one, the sum till third one, and sum till fourth one, and till so on. All the sum should be greater than equal to 0. So what is the maximum possible subsequence length that satisfies above condition? So for example, the array is 3, 2, minus 5, minus 6, minus 1, and 4. If we try to take 3, 2, minus 5, and 4, that 3 is greater than 0, 5 is greater than 0, sum till here, and this is also greater than equal to 0, and this is 4, this is also greater than equal to 0. So the maximum length of subsequence that satisfies this condition is 4. So, and the constraints are length is up to 185, and the values are up to minus 199 till 199. So what is the first idea that we can get? So we can just try to simply use a recursive function from index and the sum found till so far. So let's say we have, and we are at this index, and we have sum till this, the sum of selected transactions till the before index, and now we are at this index. So we can take the present element only if the sum of this sum of previous transaction selected and the present element is greater than equal to 0. Only then we can select the present element. So add the current element to subsequence if v of j plus sum greater than equal to 0. So the condition says that the every prefix sum should be greater than equal to 0. So if sum of elements till now selected plus the present sum greater than equal to 0, then yes, then we can take, then the number of transactions will be 1 plus function of index plus 1, and the new sum will be sum so far plus v of j, because we are considering this in the new subsequence. So the total sum will be sum plus present index. And if we do not take the current element, it will be simply function of index plus 1 and the sum, because we did not take present element, so there is no 1 plus, and the sum is also not changed. So in this way we can just simply write maximum of take and don't take. So even if we try to memorize the solution, then the time complexity will be at least 10 into 1n, because we have two parameters to memorize and the index is itself n, and sum can go from any value to many value because the values are very large and the size is also very large. So we cannot simply do this. And now let's take a random test case and try to observe what is going on. Let's say the initial array is 3, the same array that we have taken before, minus 1 and minus 4, minus 1 and 4, minus 4. So let's come to the first one. So can we take the 3 in subsequence selected transactions? Yes, because it is greater than equal to 0. So we can select any elements that are greater than equal to 0, because it will always try to add some positive sum. So we can surely take all positive elements. So 3 is positive element, so we can surely take this in the selected transactions. And coming to 2, can we add this? Yes, because even this is a positive element, this will surely contribute positively to the answer, so that we can take negative elements also. So yes, we can take 2 as well, and the sum till now is 5, and the sum here is 3, and the sum till now is 5. And coming to minus 5, can you take minus 5? Yes, because the sum of elements we have considered till now is 5, and the present element is minus 5. So is sum greater than or equal to 0? Yes, because 5 minus 5 is non-negative. So yes, we can take the current element. So we can add this to the subsequence. So coming to next one, minus 6. So can we add this? No, because the sum is 0. So we can only add non-negative elements from now. So we cannot add minus 6, we cannot add minus 1, and we cannot add minus 4 as well, because all these are negative. And the sum till now is 0. And to make the sequence move on, it must be at least positive. So it must be at least non-negative. So in this way, the answer is 3. But is the answer really 3? No, because we can take 3, we can take 3 2, and we can take 3 to minus 5. And coming to minus 1. So if we try to replace minus 5 with minus 1, the count is still 3, because even here the count is 3 and the count is 3 even. But coming to next value minus 4, we can take that now, because the sum is 4. The 3 plus 2 is 5 and minus 1 4. So 4 minus 4 is greater than or equal to 0. So if we try to replace the minus 5 with minus 1, because both are negative values as well, and even the length will not change, because we are just replacing the value, but we are not adding a new value. We are removing the before value and we are adding a new value. So even then the only sum changes and the count does not change. And finally we are able to add a new element. So the answer is 4. So what is the mistake that we are doing above and what is the correct thing that we are doing below? So from this we can understand that, let's say we have minus 100 that is considered in the selected transactions. Let's assume the first value is 189 and the second value is minus 100. So obviously we can take this and we can take this as well, because the sum till now is greater than equal to 0. And what if the next value is minus 1? So it is surely better to take minus 1 in the subsequent than minus 100. Why? Because there can be a value which can be positive because of minus 1 and negative because of minus 100, which is the case here. Because minus 4, if the value is minus 5 here, so let's say this is the before subsequence, and we are not able to add minus 4 because sum will be minus 4. But now if we are trying to take minus 1, then we can add minus 4, right? Because the sum is greater than equal to 0. So from this we are surely able to understand that if we have some negative elements before and if we get a greater number than existing negative elements, it is surely better to replace that with this, because in the future we can add some elements which will contribute positively to the present value and which will not add contribute to the previous values. So we want to store the least value till now so that we can replace it with current negative value. This is exactly what we have discussed here. So here the least value till now is minus 5. So if we try to store minus 5 and replace it with minus 1 because it is greater than this, so it can surely benefit but cannot decrease our answer. So if we try to just maintain the least negative value that we are considering, is the condition solved? No, because let's say this is the subsequence that we are considering. The first value is 11 and second one is minus 10. And now let's assume the value is minus 5. Let's assume it's 16. And then this is a valid subsequence. So the sum is 0 and the minimum is minus 10 because it's the least value that which is negative. So let's say the next value is minus 4. So we got a minus 4 and this is surely greater than the least value that is so far. So we have discussed that it is surely better to replace the least value with this so that it can benefit in future. So minus 4 is greater than minus 10. So now we are going to replace minus 10 with minus 4. And what is the new minimum value that is going to be there? Is it minus 4? Because initially we are storing only minus 10 about negative elements. We are not carrying minus 5. Because we have discussed that it is better to replace the least one. Here the least one is minus 10. So the minimum value is minus 10 and the present value minus 4, which is greater than this. So we are going to replace minus 10 with minus 4. So the new minimum value is minus 4? No. Because new minimum value is minus 4 because we have this in the past. But we are not able to store that because we are only storing the single element minimum. So minimum value is minus 5. So we cannot get the whole contribution of subsequence by only single minimum value. So we should store all the negative values, but we want the least value in O of 1 or n log n or log n. Because if we get in this, then we can try to get n log n solution, which will pass. Or even O of n solution will work and n log n will also work. So we want to store all negative values. Why? Because here is the case. If we store only the least value and if there are many other negative values, we are missing out those values. So surely we want to store all negative values, but even then we want the least value to be first so that we can try to replace that with the present value. So is there any data structure that can give us efficiently? We want the least value. So yes, we have a min heap. So min heap try to return the least value or highest value in log n. So priority queue of int, it is just the max heap, so it will return highest value in log n, but we want the least value, so we can use min heap, and this is syntax for min heap, and this will return the least element in log n. So if we try to store all negative values in min heap, then we are able to store all the negative transactions as well, and we are able to get least element in of log n as well. So by using this we can try to get answer. So if the present value is greater than or equal to 0, then yes, we can surely add because it is positive and it will surely contribute positively towards our answer. So answer is plus plus because we are considering this in the present subsequence, and the new sum will be sum plus is equal to v of g because we are adding in the current subsequence. So the sum will be sum plus v of g. And if the element is negative, so what if the current element is negative? So let's say the sum till now is 10 and the negative element found now is -1. So can we take this? Yes, because sum is surely greater than or equal to 0 and is greater than 0, then we can consider it. But what if the value is 10 and the value is -11? And if it's the case, then we have to check whether there are any previous negative elements so that we can replace with this. Let's say we have 100 and we have minus something. So if we have some negative elements, then we can try to replace it with the present value, and then we can check whether we are able to make some positive or non-negative. So if sum is less than 0 and if there are no negative transactions as well, it means we only have positive elements in subsequence, and surely we cannot take negative element because there are no negative elements. So obviously we can't add. So just continue, and else it means that we have some negative elements. So get the least value. So pq dot top returns the least value. pq dot top returns the least value in the priority queue. So we will get the least value and we are popping. So we are removing that. And if the present value is greater than the least value, so we have discussed here, if -10, this is the x and the present value is -4. So is this condition satisfying? Yes. So it means that we are going to replace -10 by -4 when x is less than v of j. So when v of j is greater than v of x, it means that we are going to take the present element in the current subsequence so that we are replacing the old value. So we have already popped it and we are adding the present element to priority queue because we are taking the present element in subsequence. Because we are replaced the least value with present value. So you are pushing, and what will be the new sum? The new sum when we are considering x is sum. So we are removing x, so it will be sum minus x, and we are adding the present element. So it will be sum plus v of j minus x. So if the value of vj is greater than x, then we are replacing the element. But if it is not less than the element, we are just pushing the top element initially. So let's say the initial least value is -100 and the present value is -10. Then yes, we can try to replace it. But what if the least value initially is -10 and the present value is -100? So surely it is ways to replace it. So we will just push this initial value that we have popped, so that we are not going to replace the present element. So if v of j is not greater than x, we are simply pushing the initial popped element. And this condition is when the sum plus vj is greater than 0. So if sum plus, so this is the case. And even if the present element is negative and the sum is positive, then we can add in the subsequence. So answer plus plus, and we are adding in the sum and we are pushing because this negative element, though it is a negative element, we are having sum plus vj greater than 0. So yes, we can add it, and as this negative element we are storing in priority queue. So in this way we can just try to maintain answer and sum, and we can store negative element in priority queue so that we can get least values in of log n, and it will fulfill our condition. So it is simply the same case. If it is positive, we are adding, and it is negative, we are just taking cases. So in this way we can return the answer. If you have any doubts, comment below. Subscribe for more updates. See you in the next one.